Welcome builders, architects, and product teams to this explainer. Today, we're taking a senior architectural look at a system designed to fix what is honestly one of the most frustrating, totally broken workflows in modern software engineering. We are talking about how to give our AI tools actual persistent memory. Okay, let's dive into this because this is a deep, daily pain point for pretty much every developer right now. You sit down, you open up your AI coding assistant or chat client, and you literally spend the first hour just teaching the AI about your system. You're pasting in architecture designs, naming conventions, known bugs, deployment rules, and the AI gets it. It's brilliant. But then you switch AI clients, or the session times out, or the underlying model changes. And poof, all of that incredibly hard-earned project context just vanishes. You're completely back to square one. Right now, the industry standard is basically just temporary AI memory. It's highly ephemeral. The usual workaround is this massive, repetitive copy-pasting cycle. You end up dumping 20-page requirements documents into your prompts over and over again. It's incredibly inefficient, it's brittle, and honestly, it burns through a ton of tokens. But imagine if we replace that with persistent project memory, a robust knowledge layer that actually survives your individual AI sessions, works across totally different AI clients, and persists even as those underlying language models evolve. To understand how we actually get there, we're going to walk through this explainer almost like we're doing a technical RFC review. We'll hit 1, the AI context problem, 2, introducing Notito project memory, 3, the architecture of deterministic truth, 4, human and AI co-working, 5, core mechanics and MCP, and finally, 6, the actual engineering and business value. All right, section 1, the AI context problem and what we call the ephemeral context bottleneck. You see, when you're building software, the code itself is really only half the picture. The rest of it is context. It's your architecture designs, your highly specific naming conventions, past architectural decisions, explicit API contracts, security constraints, and deployment rules. Under the current standard model, all this absolutely crucial knowledge vanishes the second you close the window. The AI is incredibly smart, but it has severe amnesia. Which brings us to section 2, introducing Notito project memory, the persistent layer between humans and AI. When exploring a system like this, precise definitions really matter, so let's establish the technical boundary right out of the gate. I need you to completely wipe the phrase note-taking app from your mind. Notito is a project-scoped, linked Markdown memory system where humans and authorized AI agents work on the same durable project knowledge through deterministic search, references, graph projections, schemas, revisions, and MCP. And this brilliantly illustrates the new paradigm. Notice the flow here. Instead of humans feeding context directly into a black box AI model, both the human and the authorized AI agents sit on the outside. Right in the center is the Notito project memory. The human writes to it. The AI agent reads from it and writes back to it. The AI client can change, the model can swap out tomorrow, the conversation can end, but the project memory remains permanently anchored right there in the center. Let's move to section 3, architecture of deterministic truth, specifically focusing on the Sprint 10 structural refactor. In Sprint 10, the engineering team stripped away the magic and established a very strict separation of concerns. On one hand, you have notes, which represent your canonical project knowledge. These are pure, portable Markdown files with an immutable revision history. Then, entirely separate from notes, you have schemas. Schemas act as first-class structural contracts. They are project-local and versioned. So you might start out with a default freeform V1 schema, but when you need strict governance, you can bind a note to a decision V1 or API contract V1 schema. So the crucial point here is this critical intelligence boundary. Notito handles deterministic storage, validation, search, and versioning. The AI agent handles reasoning, query reformulation, planning, and synthesis. Notito does not need an internal LLM to work. It is purely deterministic. The AI agent provides the intelligence, but it absolutely does not own the project truth. This lets us completely bust the myth of the hidden AI brain. In Notito, all the fancy features, the search indexes, the automated backlinks, the visual 3D graph topology, the concept facets, these are all just derived projections. They are strictly rebuildable derivations from the canonical Markdown. Derived data must never become a second hidden source of truth. The Markdown is the truth. Let's move to section 4, human and AI co-working, and how we share canonical knowledge. The foundational product thesis of Notito is beautifully captured in this quote. Knowledge should be equally usable by the person who created it and by the AI agents they explicitly authorize. By forcing both humans and machine agents to read and edit the exact same canonical Markdown text, Notito completely avoids the trap of creating this invisible, diverging AI memory that the human can't easily inspect. Because humans and AI are working on the exact same text, relationships are completely explicit. When you or an AI agent writes a wiki reference, like putting double brackets around architecture decision, that creates an explicit authored relationship. There are no opaque, fuzzy AI guest targets secretly rewriting your links behind the scenes. The result is absolute portability and predictability. Section 5 takes us into the core mechanics and MCP, safe mutations and portability. How do we actually make this safe for machine interaction? Because letting autonomous agents write to your project documentation sounds terrifying if you don't have the right API contracts. Under the Model Context Protocol, or MCP, an AI agent operates surgically. It doesn't ask you to paste a massive file. Instead, the agent autonomously searches notes deterministically. It follows references and backlinks from node to node. It reads exact, bounded sections, maybe just a specific heading, and then it reasons and synthesizes that precise context. Now, what's really interesting about this slide is the precise edit operations happening here. An agent doesn't need to rewrite an entire 20-page document just to change one single paragraph. Instead, Notito uses precise typed operations: append, insert before, replace section, and so on. Furthermore, these mutations require an expected revision ID. This concurrency control means if you have a stale AI agent, it'll fail safely rather than silently overwriting the newer work you just did as a human. For the security-conscious architects out there, I see you. And the Sprint 12 MCP rules lock this down tight. Authentication does not equal authorization. Notito implements universal cross-client compatibility, working safely with Codex, Claude, Cursor, and generic MCP clients. It enforces strict project isolation boundaries so scopes can't leak across projects. It defaults to least privilege, read-only access, and strictly prohibits downstream token pass-through. It operates as a governed, vendor-neutral standard. And finally, Section 6, Engineering and Business Value. Let's talk about the real ROI of persistent context. We've looked at the architecture, but when we compare these workflows side by side, the difference in team velocity is just stark. Before Noto, your team is suffering through ephemeral AI sessions with hidden diverging context. You're wasting tokens and time on massive copy-pasting and totally brittle document rewrites. But with Noto's deterministic project memory, you gain persistent AI memory that survives the session. You have shared knowledge between your engineers and your tools. You drastically reduce context repetition, and your agents can make precise, revision-safe edits with immutable history for instant recovery. And it really all boils down to this number right here, 1. The ultimate goal here is exactly one canonical source of truth for your project. A single, durable, Markdown-based layer that your human engineers and your language models can both read, trust, and build upon. The AI tools we have today are incredibly powerful, but they are starving for persistent context. Notito provides that governed memory layer to solve this exact problem. So the question is, now that your AI agents are actually ready to remember and work alongside you, what will your team build with persistent project memory? Thank you for joining me on this explainer, and happy building.